So in this example, we're given a circuit that has a voltage source, 36 volts, DC source, and then we have a DC current source of 9 amps. And they're asking us to use superposition to find the current in R1. So here's R1. So we're looking for the current flowing right here. So when we use superposition, remember we calculate the contribution from each source separately. So let's take a look at how we might do that. So if we consider the current source first, remember when we do superposition, any other voltage sources, we short those out. So that would be as if this device here were gone and replaced with a short circuit. So that would be here. So when we do that, we notice then that this R4 resistor is also shorted out. So it's as if it's not even there. So that being the case, we can just eliminate this one as well because it's just been shorted out. No current will flow through that. So now, with this being the case, we're just left with the remaining circuit here, and we see that this is just a current divider. So now, when we have these two resistors here in parallel, or excuse me, in series, these two here, we just add those together. So that being the case, we should just be able to replace them with one resistor of 12 ohms. But either way, we're just doing current division. So, we have this current coming along here, and when it comes to this node, some is going to go this way and some is going this way, and this is what we know is our common current divider. And so we have current division. We know that I is going to be equal to IT, which is the total, times, I call this R other for the other resistor or the other branch that we're not interested in, plus R total of the current divider. So in this case, we're solving for the current through this resistor here. So then we could say I R1 from source 1. That's going to be equal to I total, which is 9 amps. And then we've got our other branch, which is this branch here. It's just going to be the 6 plus 6 resistors. And then the total is going to be 6 plus 6 plus 6. And so when we calculate that out, this will be 9 times 12 over 18. And then what we should get when we calculate that is 6 amps. 6 amps, and that's going to be going down. So, because the current is going up in here, and it'll be going down. So we will designate that with the down arrow, 6 amps in the down direction. So that's the current from the current source through R1. So now we need to go back and use superposition and consider the other source. So let's do that. So if we were to come back up here and reset our circuit, so here's what we had originally. So now we want to consider the voltage source here. So when we do that, we open circuit our current sources when we do superposition. So that being the case, then it would be like we could take this entire leg of the circuit away. It's not going to exist because we opened that circuit. So there, that's all gone. And so now we're left with, again, another form of current division. So we'll have current flowing. Now this is the positive side here, so we're going to consider current really coming from this way. And then when we get to this node, some of the current, of course, will go this way, some will go this way. And this is really the one that we're concerned with because it's the one going through our 6 ohm resistor. So the first thing we need to do is calculate this I total here. And to do that, we're going to need to find the equivalent resistance seen by the source number 2. And so when we look at this, what we really have then is an 18 ohm resistor in parallel with 6 plus 6 plus 6 ohm resistor. So that's really just 18 in parallel with 18. Well, we know from common theory that when we do that, that just halves the resistance. So that's going to be 9 ohms. So the equivalent resistance here would be 9 ohms. And so that means that the total current is going to be our voltage over our resistance. That's just Ohm's law. And so that's 36 over 9. And so that's going to be 4 amps. 4 amps. So now to get our current, we'll call it R1 from the second source. Again, it's just current division, right? So we have our I total. We can just go ahead and fill in the values here. So our I total is 4, and then that's going to be the path that we're not interested in is this 18 ohm resistor. And then that's going to be over 18 plus the resistance in the other leg, 6 plus 6 plus 6. And so that's going to give us 4 times a half, or that's going to be 2 amps. But in this case, the amps are flowing upwards through the resistor, so we're going to put an up arrow sign there. So there's the current from the second source. So now through superposition, we can find the current through R1. It's going to be the current through R1 from the first source plus the current through R1 from the second source. So in this case, the R1 from the first source is the 6 amps. Remember, that's going down. But then we've got this current from the second source, and that's going up, so it's working against us. So we're going to have to put a minus sign there, minus 2 amps. And so when we calculate that out, the total current through that resistor should be 4 amps going through R1.